In this tutorial, we take a look at using the toolpath templates feature, which is designed to save time in creating toolpaths for sets of vectors in similar jobs. We demonstrate how we need to organise our vectors and also create our toolpaths in a specific way, which we can then use over and over again on similar jobs, saving us lots and lots of time. So let's start by opening a new copy of the software, and we're going to be opening an existing file. Let's navigate to the projects folder and select the sample cabinet.crv and click open. Now this is a file that's been specifically created to demonstrate to you how to set up a toolpath template which we can then use on similar jobs in the future. Now we don't have to necessarily use vectors like we have got on the screen at the moment, which have been created in a cabinet maker's design package. We can also create these vectors ourselves within the software package. The key to creating a toolpath template is actually the organisation of our vectors. Now if we go to the Layers tab, we can see that we've got quite a lot of layers here. And each of these layers that you can see on the screen at the moment holds vectors relating to a certain type of toolpath. So the idea behind this is that we group our vectors that we've got so that when we come around to actually creating the toolpaths for them, we can then use the vector selection method within the toolpath to actually select certain types of vectors on that particular layer. And these layers that you can see on screen at the moment have actually been imported along with the vectors which come in a DXF format from this cabinet maker's design package, and it has actually retained that layer information. And so any further cabinets that I decide to make in the future on this particular software, when I come to import them in, we will have the same layer information and hopefully the same vectors relating to that, so that when we do actually utilise the toolpath template, it's going to look straight away for the particular vectors that we're going to specify on that particular layer, then apply the toolpath to them, which in the long run will save us quite a lot of time. So let's take a look at what we've got on our layers. So we've got the first three layers seem to have holes, drill holes on them. So let's just turn the visibility on and off of these just so we can see what vectors these are associated with. And then the next 6 layers look like they are all dadoes. So let's just turn the visibility on and off on these. Now each one of these different layers is going to have its own toolpath associated with it. Even though they may have exactly the same settings, it may just be for the benefit of that in the future, if we do decide to change the cut depth, for instance, on one particular set of dadoes, then we don't actually have to then go ahead and manually edit and create new toolpaths for all the different dadoes that all have different cut depths. Another handy feature about the layers list is that we can actually also see within these icons here that all of the layers actually do have vectors on them, and that the active layer at the moment is the cut layer. So if we did go ahead and create any more vectors, that would be applied to the cut layer. If we wanted to actually make the vectors active on a particular layer, we would just click on the icon next to the layer name. So if I wanted to turn on or make active and selected the current vectors on the bottom blind dado, I would just simply left mouse click on this icon here and go to the select layer vectors. And we can also do the same function by simply right clicking on the actual layer name. So if I right click on bottom blind dado, I also get that same menu as well. So now we can see, and we've got an idea of where all the vectors lie within our layer list. The next thing that we're going to do now is actually size up our vectors to decide what type of toolpath that we may be applying to each of these vectors. So I'm just going to go ahead and just zoom in a bit on these bottom blind dados. So if I just zoom in here and then I select one of the dados, you will notice that down the bottom right hand side of the software it actually gives us some details about this vector. So we can see that the width of the vector is 0.625 of an inch, and it's got a height of 23 inches, and it also gives us the actual layer that it's actually on as well, so bottom blind dado, which is this layer here. And what we can do is we can simply try and work out what type of toolpath we're going to apply. Now I know that I'm going to be using a 3/8 of an inch end mill tool for the dados, so in decimal format that would be 0.375. Now, because the width of this vector isn't more than twice the diameter of our tool, we could actually just simply use a profile pass to actually machine out our dado here, as we could just do a profile on the inside of these vectors, and that would do the same as what would be achieved if we did a pocket, and it would also be a lot more efficient than doing a pocket toolpath as well. So we can actually go around all the dados that we've got here and just size them up and to see which layer they are on, and just to see which dados we can get away with actually using a profile toolpath, whereas the likelihood of this one here, you'll see that the actual height of this is actually more than twice the diameter of the tool that we're going to use. So this one we would actually have to use a pocket toolpath. And this is more just for efficiency of the actual running of the machine more than anything. But I've gone around and checked all of the dados on my vectors and layers. So what I may want to do is actually just organise the order of my layers in the layer list before I actually go ahead and actually create my toolpath, just to give me some kind of, or make it easier for me when it comes to actually creating the toolpath, which dados I'm actually going to be profiling and which ones I'm actually going to be pocketing. Now I can tell you that I've already done this for you. So the top 3 dado layers are all going to be for a profiling toolpath, and the bottom 3 layers are all going to be using a pocketing toolpath. So now we know this, what we can do is we can go over to the toolpaths tab and actually start creating some toolpaths. Now I actually may want to have the layers list open at the same time as creating my toolpath, so what we can do is we can actually keep this open as well as having the toolpaths tab open. So if I just hover my mouse over the toolpath and just simply click this here to then pin or keep open that tab as well. So before we begin any toolpath creation, we must always check our material setup. So let's just click that button in the top corner here, and let's just double check our details. So we've got 3/4 of an inch thick material, we've got our Z0 off the top of the block, and our XY datum position in the lower left, which is all correct. And we just need to check now our rapid Z gaps and our home and start position to make sure that these are all safe levels for our machine. So I can see that those are all okay, and so we can just press OK to accept our material setup. And we're going to start with some easy toolpaths, so we're just going to start with a standard drilling toolpath. So I'm just going to deselect all my vectors, as when we're actually creating our toolpath template, we want to make sure that we've got no vectors selected, as we're going to be using the vector selection method within the actual toolpath form to automatically select our vectors for us. So let's go into the drilling toolpath, and we're going to be drilling from the top of the material, so just keep that as 0, 0, and we're going to be drilling down to a depth of 1/2 inch, so let's just change that there to 0.5. And the next option is for us to select a tool, so let's press the select button to open our tool database. I'm just going to go down in the imperial section to our drills section, and I'm going to use this 1/4 inch drill bit that we've got here. I'm just going to accept the standard speeds and feeds for this tool and just press OK. Obviously, if you do plan on running anything on your machine, do please check the speeds and feeds and cutting parameters first. And once we've done that, just press OK. I'm not going to use any of the further options of peck drilling or to dwell at the bottom of each pass or the vector selection order. I'm going to go ahead now and actually use the vector selection method here to automatically select my vectors. So let's just press the selector button, and we're going to be going down the layer list from top to bottom. So the first lot of vectors that I want to create is our hinge holes. So what we do is the first section we come to is the type of vectors to select. Now we know that they're circles and we know that they're going to be closed vectors, so let's just make sure that this option is checked here. Now under the actual closed vectors section we have 2 options, and these are all closed vectors. Those can include all sorts of different shapes, or we can specifically select just to only select closed vectors that are circles. And within the circles option we do have other options as well to actually match specific diameters or match the actual tool in size, whereas I just want to actually just select all the circles that are available on the layer. So once we've got this option selected, we can then move over and actually specify the layer that we actually want to select the holes on. So I'm going to choose this option here to select vectors on this layer only, and then I'm going to check the checkbox next to the hinge holes layer, And this will now look for, if we just move this out of the way, you'll see that all the holes that are actually on the hinge holes layer are actually now selected. Now if we want to actually use this efficiently in a toolpath template, we need to make sure that we then associate all these rules with this particular toolpath. So that obviously if we do then go to use it once we've loaded in our toolpath template in future cabinets that we may make, when it loads back in this toolpath, it will actually remember to actually select the vectors according to these rules. Now we need to select this option here to associate all these rules with this toolpath. And once we've done that, we can rest assured then that all the time that we recalculate this toolpath, that it will actually look for any new vectors or any vectors that abide by these rules within the hinge holes layer. So once we've done that, we can click close and we can just give this a name. Now because we've got a few layers that have all got drill holes in them, I may just want to actually just copy the name of our layer. So to do that, we simply just click it once and then click it again to then highlight the actual text, and it also allows us to rename it. But I just want to copy the text, so I just want to hover my mouse over the highlighted text, right click on the mouse button and then come to copy. And then down here I'm just going to click into the name field, remove the number 1 there, and simply right click again and then use the paste function. And once we've done that, we can simply click the calculate button and we can even preview that toolpath as well, like so, as you can see. I'm just going to go ahead now and do the rest of the drill toolpath. So I'm just going to close the preview toolpath form and I'm going to open the drill toolpath form again, and you'll see all the settings that we've got here are all the same as they were before, and that's because the software remembers what last settings you actually used for this particular toolpath. So this is going to make this nice and simple. So all I need to do is go down to the vector selection and press the selector button. Again, we're going to be using the closed vectors option and selecting only circles on the layer this time for the shelf holes. So just check that option there and deselect the hinge holes. Again, make sure that we're going to associate these rules with the toolpath and then press close, and again just click once and then click twice. And this time we can actually use the keyboard shortcut of holding the control key down and pressing the letter C as well at the same time to copy that. And then we can come over to the name field, click in it again, delete the number 1, and this time to paste it we can use the keyboard shortcut again of holding the control key down and then pressing the letter V at the same time, and that will just paste that in there as normal. And then we can go ahead and then calculate this toolpath as well, and we can give that a preview like so. So I'm just going to go ahead and finish the last of the drill toolpath. So I'm just going to close the preview toolpath form, go back straight into the drilling toolpath form, keep all the same settings, and then choose the selector, and then choose the drawer holes and deselect the shelf holes. Associate with the toolpath, close, take the name from the layer, go to the name field and just paste that in there, and then click calculate and then preview. So that's all the drill holes that we've got so far. So now we can move on to toolpathing our dadoes. Now we know that the top 3 layers, we're going to use a profiling toolpath for that. So let's go ahead and select the profiling toolpath, and we know that we're going to be starting from the top of the material, and we're going to cut our dadoes to a depth of 3/8 of an inch. So just type in there 3 divided by 8 equals, and that gives you then the decimal value for the depth. And the next option that we've got is to select our tool. Now if you remember that we did discuss that we were going to use a 3/8 of an inch tool for that as well. So let's go into our tool database, and as you can see from our end mill section, we don't actually have a 3/8 of an inch tool. So what we can do is you can simply highlight the end mill of a 1/4 of an inch, and we can simply just use this button down here once it's highlighted to copy all the information from the 1/4 inch to use it as a basis for our 3/8 of an inch tool. So once we've actually copied it, you'll see that under the end mills we've now got 2 1/4 inch tools. So with this one highlighted, I'm just going to go ahead and change the name to a 3/8 inch end mill, as if we don't, we may actually save all the rest of these settings here as a 3/8 of an inch tool, but when we come to select it, we won't actually know which one we've actually selected because it's only going to demonstrate that we've actually using a 1/4 of an inch end mill. So just make sure that we've got the name changed, and then we can go ahead and change the diameter of the tool as well to 3/8 of an inch. And we can then specify the rest of the cutting parameters and speeds and feeds. So I'm going to have a pass depth of 3/8 of an inch. So just type that in there. And then I'm going to have a step over of 40%, that's fine. Just going to have a spindle speed of 12,000 RPM, a feed rate of 300 inches a minute, and a plunge rate of 60. And once we've got all that, obviously, if you're going to be running this on your machine, make sure that these actually apply to you. And once we've done that, press OK. Now our next option is to choose whether we're going to be machining our vectors on the outside, inside, or on the actual vectors. Now because we're doing the dadoes, we're going to be machining on the inside of those vectors, if you remember. So we're going to select this option here. And then we're going to skip the rest of the options, and we're going to go down to the vector selection. And again, we're just going to choose the selector, and this time we are going to want to change this to all closed vectors and not just circles, as otherwise it won't pick up our rectangular shapes for our dadoes. And then we're going to change the layer to the bottom blind dado, so just check that option and then uncheck the drawer holes, and then again associate all these rules with the toolpath and then click close. Now if we switch back to the 2D view, we should now see that those dados have been selected. And all we need to do is simply, again, just copy the name. Now the only reason we're actually copying the name is so that obviously we have some relation to what this particular toolpath is doing and what it's actually machining. So let's paste the name in there and then just click the calculate button. Again, if we want, we can just preview that, and we can actually apply a colour to all our toolpaths, so that just makes it easier to view in the 3D view. And I'm just going to go ahead and close this, and then go ahead and create the other two profile toolpaths. So I'm just going to go into profile again. It's actually remembered all of our settings again, so all we need to do is just simply scroll down to our vector selection, press the selector button, and then just change the layer to side blind dado, uncheck the bottom blind dado, and again associate with the toolpath and close. And we'll just give this one the name as well. So paste that and then calculate, and we can preview that one as well. And then we can do the final profile toolpath. So I'm just going to go ahead, click on the profile toolpath, go to the selector, choose the top blind dado, uncheck the side blind dado, associate with the toolpath, get the name of that particular layer, and then paste that into the name, and then calculate again. And we can just preview that. And now we can close the preview toolpath form, because now we can concentrate on the last three sets of dado layers, and these are going to be pocketing toolpaths, as the width of the vectors was more than twice the diameter of our tool. So let's choose the pocketing toolpath, and let's start setting our parameters. So we're going to start from the top of the material, as we know, and we're going to be cutting down to 3/8 of an inch. So let's just, again, let's just get used to using the math library built in. So 3 divided by 8, and then press the equals key on the keyboard. Then we can move down and select our newly created 3/8 of an inch end mill and press OK. Now for this particular toolpath on the pocketing, I may actually want to change some parameters purely just for this pocketing toolpath. So what we can do is we can actually use this edit button here, and this will temporarily change the speeds and feeds for this particular toolpath and not amend any of the settings within the actual tool database. So what I might want to do is actually change this step over from 0.15 or 40% and actually change that to 1/4 of an inch, so we can actually really get through pocketing these dados. So once we've done that, we can press OK, and then I'm going to choose to have a rastering strategy of climb as well, and I'm just going to set the angle to 0 degrees. I'm going to select to profile last. Then we can scroll down and then go to the vector selection and just choose our layer. So we're going to be selecting all closed vectors that belong to the layer back bottom dado, so just check that option and then uncheck the previous layer that was selected. And then just come along again and associate with the toolpath, and then click close. Now, just going to copy the name from the layer again, and just paste that in there. And we can go ahead and preview that one as well. So I'm just going to go ahead and create the last two pocketing toolpaths. And as you'll know, that the settings will have stayed the same. And even if we press the edit button, you'll notice that it has also saved our extra step over that we actually added to our tool just for the pocketing toolpath that we just created. So we can go ahead and OK that, and all we need to do is again change our layer. So I'm just going to go ahead and do that, and then change the name again. Now this may seem like a lot of work that we may be doing here, but it will obviously pay off, as all we need to do is actually create this set of toolpaths once, save out our toolpath template, and all we need to do is every time that we actually import vectors that we've created from our design package, all we need to do is apply our toolpath template, recalculate the toolpaths for whatever sheet we're on or whatever vectors are on our screen at the moment, and it will automatically apply all those toolpaths to the layers and all the vectors that we've actually got, that we've imported. So it does actually make life a lot simpler and a lot faster in the long run. It just takes a bit of time when we're actually setting it up. So I'm just going to go ahead now and create our last pocket and toolpath. So I'm just going to go straight down this time, as I know that all the settings are correct, and just select our last dado toolpath. And then click calculate, and then we can preview that. Now the last toolpath to create is actually our cutout path, which is going to go around all the parts to actually then cut them out. So let's go ahead and create ourselves a profile toolpath. Now we're going to be starting from the top of the material, so we're going to start with a depth of 0, 0, and we're going to be cutting down to the full depth of the material. So just type in there Z and then equals, and that will just pick up the Z depth of the material that we specified when we first started, or when we first created the material setup. Next is to specify our tool, so we are going to be using the 3/8 of an inch end mill. We can actually just quickly check to make sure all the speeds and feeds and parameters are OK for our toolpath, and then click OK. Now, because we're going to be cutting these out, we actually want to be machining on the outside of our vectors, so make sure that this is selected here, and we can scroll down and just go down to our vector selection. So just press the selector button once more time, and we're going to be selecting all closed vectors and only on the layer cut, and we are going to associate this with the toolpath, and then we can just close that. Now just make sure we've got all the vectors that we need to select. We can go into the 2D view and just ensure that they are all selected there. This also helps us identify as well, doing it this way, that to make sure that any vectors that we may have imported are actually all closed vectors, because obviously if we do go to do a profile toolpath around them, that actually also may affect the result of the profiling cutout if we don't actually have a closed vector. But I can see all the vectors are selected there, so I'm just going to go ahead and just call this profile cutout, and then click the calculate button. And then we can preview that, just to preview exactly what we'll actually be cutting out here as well. So we could go ahead now and close the preview toolpath form and save out all of our toolpaths individually, and then run them on the machine to actually get this product created. But the whole purpose of actually creating our toolpaths and actually layering our vectors in this particular method was to actually make use of the toolpath template feature in the software. Now this actual layout is also handy for if we wanted to actually make multiples of this particular design as well, and we could use the nesting feature. And because of all the toolpaths actually have the vector selection for particularly picking out vectors in particular layers, all we'd need to do then as well, if we actually run the nesting feature, is actually recalculate all the toolpaths, and that would then create multiple sheets and multiple toolpaths for us to run to make multiples of this particular design, whilst saving more space on our sheet, so maximising the space of our material. That, however, is all covered in a specific tutorial all dedicated to nesting, and it's definitely worth a watch along with this video. Now moving on to actually creating our toolpath template, once we've actually got this far and we've created all of our toolpaths, we've assigned the vector selection to be automatic for the particular layers that we've actually organised up here, or we've actually imported all the layer information from our cabinet design software, then all we have to do then is actually come to this icon here. Now we could actually save each individual toolpath as its own individual toolpath template, or we can actually save all the visible toolpaths as one big template. And what that will do is that will save them all, and then if you did then load in this particular file and you don't happen to have one of the layers on there, then it will just warn you that that particular toolpath isn't of any use for your particular job, but it won't actually affect it in any way. So you can actually put more and more toolpaths in this, and it will actually become quite handy. So what we're going to do is we're going to actually create a toolpath template with all our toolpaths in there. So we're just going to make all these toolpaths visible. So to do that, we just select this option here, and that will then select all the toolpaths. As you can see, all the checkboxes now have ticks in them, and we just need to select this option here, and we just give our toolpath template a name. So I'm just going to keep mine as the sample cabinet.toolpath template file and just click save. And what we're going to do now is we're actually going to close this file, and we're going to open up a new file and then import a load of vectors as if we're actually have just created these in a cabinet maker's software. So before I do that, I may actually just want to save my progress here. So file, save as, I'm just going to call this sample cabinet -toolpath, and just press save just so I can go back to it at any time and then alter these in case I need to make any edits to the toolpath template. And I'm just going to go ahead and file and then close. And what I'm going to do now is I'm going to demonstrate to you how we go about creating a new file with all the exported vectors that we have created from our Cabinet Maker's design package. Now, some Cabinet Maker's design packages actually may export these vectors as DXF files, and then they also might actually export them so that for every vector that's been created, they may actually export a DXF file purely just for that one vector. So we may actually end up with quite a lot of DXF files that we actually need to import into this software. So it may not be done on a per layer basis. So if I just show you actually all the files that we are actually going to import here, you'll see that there's actually quite a lot of vectors or DXF files to actually import here. And they're actually only still using the same layers that we actually created our toolpath template with. So what we're going to do is we're actually going to take advantage of one of the gadgets that are actually shipped with the software. So if we go up to gadgets before we actually go ahead and create any file, and then just go down to the DXF batch processor, this will actually bring up a gadget. And what a gadget is they are little programs or routines that automate certain processes. And you can find out more about different gadgets that are available for your software if you just go to gadgets.vectric.com on the web. Now this particular gadget is actually going to create our job, and it's also then going to import all the DXF files that we specify in this directory that we're going to choose here. So if I just go to the choose button, and I'm just going to choose the nested cab files, and I'm just going to choose this file here for cabinet design files, as I know that all my DXF files from the design package that we use to create them are in there. So I'm just going to click OK on that. And then also we can have the option to process any subdirectories that happen to be within the folder that we just selected. So I don't believe there is any, but we can just leave that selected anyway. And we can then go ahead and actually specify the way we actually want to lay out each of these files or vectors that are going to be imported off each DXF file. So the number of drawings in a row I'm going to specify as just 3, and the gap between each of the drawings I'm just going to put 4 inches in X and Y. So, and if we just go down further down the options, we can now specify our job dimensions. So I'm going to specify a standard sheet of material, so that's 96 by 48, and if you remember, our part was 3/4 of an inch in thickness. So I'm going to make sure that that's specified in there, and then I'm going to move on to the next options. And so we're going to be working in inches, and our XY datum was in the lower left, and we are working from the top of the material. So once we've actually specified all those options, all we need to do then is just press OK, and that will then create us a new job and import all of the vectors. Now this has come up as it's noticed that we haven't actually created a job yet, so what it's going to do, it's going to create one for us with the job dimensions that we specified, like so, and now it's just given us a message to let us know that it's actually imported 56 different files that it's processed. So once we've done that, we can just click OK, and then we can actually take a look at our vectors. Now you can see that all of these have actually burst out of our sheet, which we actually specified down here. So we're going to have to organise these vectors onto separate sheets of material. So the way we do that is we simply highlight all of the vectors. So I'm just going to draw a box around all of those there, and then we go to the nesting function, which is here, and then we just specify a few options. Now I'm not going to go into great detail of exactly what we're going to do here. There is, as I've mentioned, there is a great tutorial which goes into great depth about all of the features and all the different ways of nesting that you can actually do, depending on obviously your type of job. But I'm just going to go ahead and just list a few here. So I know that my tool diameter is 3/8 of an inch, and then I want additional clearance of 1/4 of an inch. So I'm just going to type in 0.25 in there. I'm not going to have any border gap. And for nesting the parts, I'm going to rotate them in a rotational step angle of 90 degrees, and I'm going to nest from the lower left hand corner along the Y axis. I only want one copy of all these, so I don't want to make multiples of what I've already got. So I just want to click apply and then preview, and then this should then generate all of the sheets that are needed to nest all of the vectors. So you can see it's put all of our vectors onto 7 separate sheets. So I'm happy with that, so I can simply just click OK and then start working with our sheet. So just to let you know how to get in between different sheets, we just simply double click the grey area or the sheet that's actually greyed out at that particular moment in time, and that will then make this the active layer. And now that we've organised our vectors onto different sheets, we can go straight over to the toolpaths tab. So I'm going to do the same again. I'm just going to bring out the toolpaths tab and pin that open, as I want to actually check out our layers. So as you can see, all of the layers that we mentioned and that we'd actually created toolpath for in the previous file that we actually had open, you see they're all here. We do have the addition of 2 extra layers, but you can see that from this icon here, it has no shapes within it. So that means that there's no vectors on that particular layer. So we could actually just delete those if we wanted to, like so, as they actually have nothing on them. So what we do now is we simply come over to the toolpaths tab. We press this button to load a toolpath template. We find the toolpath template that we created and then press open, and it will then list all the toolpaths that we actually created for our particular layers list over here in this list here. And what it will do, once we press to recalculate all the toolpaths, it will recalculate all the toolpaths that actually have anything relating to the sheet that we have active at the moment. So if we just demonstrate that now, so if I just recalculate all the toolpaths, you'll see that we've got an error message come up which says basically that whilst recalculating all the toolpaths, the following toolpaths actually didn't have anything to recalculate with. And this is all because on this sheet that we've got here, the only toolpath that it could create is the actual profile cutout path, and that's because it's got no dadoes or any drill holes on this sheet at all. So it's just giving you a warning about that, and it's good because it lets us know that what toolpaths are available to us. Now the ones that we can actually save out are the ones that are all visible, so the ones that have a check mark next to them in the toolpath list. So what we'd do is we'd simply highlight it and come to save a toolpath. We would obviously choose, if we can combine the toolpaths into one, that's even better. We could do that as long as they use the same tool. We'll choose our post processor and then go to save the toolpath. We'd save it with a name, so we'd go like sheet 1 profile cutout, and then we'd save that in a folder, maybe a folder named sheet 1, just to help us differentiate that particular profile cutout from, say, sheet 2's profile cutout. So let's just close that, and then what we would do then is we would then select another sheet, so sheet 2 for instance, and we would just do the same again. So we'd recalculate, and this time it tells you that there's no top line dado toolpath for it, and there's no backtop dado toolpath as well. And you can also tell that because in the toolpath list they're not actually selected as being visible at the moment. So again, we'd just go ahead and save out all those toolpaths with a relevant name, letting us know that it's for that particular sheet. Now, if you do a lot of work with different sheets and you do want to actually take advantage of using the toolpath template, there is a great gadget on the gadgets website, so gadgets.vectric.com, in which all you would do is you would import the vectors as we did to start with. You would then nest them so that we've got them nested on all different sheets like this. And all you would do is, rather than using this load toolpath template option, you would go to gadgets, then you would select the apply template to all sheets. You would then navigate to that toolpath template, and then the gadget will actually automatically apply the toolpath template to every single sheet for you automatically, with the option also to actually create the post-processor code directly without having to then go ahead and then save all the individual toolpaths. But it does actually create the toolpaths for you, and that will be indicated by S1 underscore and then the particular toolpath name, and then S2 for sheet 2 and then S3 for sheet 3. And that now brings us to a finish on this tutorial. I hope you've learnt something new. So thank you for watching.